Hello students, welcome to RD Chemistry. I'm going to start a new playlist called as the Reagents in Organic Chemistry, and today's topic is the Grignard reagent. Please like the videos, share the videos and subscribe RD Chemistry. Also please write down the comments and support me. Thank you for watching. The general formula of the Grignard reagent is RMgX. 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 Here R is from the alkyl. R is either alkyl or from alkene, alkenyl. From alkene, alkenyl. From alkyne, alkynyls. Alkynyls. And also from the aromatic ring, that is the aryl phenyl. What are the X here? X is equal to halogen, chlorine, bromine and iodine generally. Okay. Now, here we have got magnesium metal, correct? For example, I have got R is equal to methyl, CH3. Magnesium and halogen, let it be Br, correct? So, carbon is attached to the hydrogen, hydrogen and hydrogen. Then attach the magnesium, then attach the Br, correct? Here, carbon is attached to the metal part. So, methyl group is an organic compound. Okay, so it is organo. Magnesium is a metal, so it is a organometallic compound. Grignard reagents are also called the organometallic compound. Okay, organometallic compound. Now, how to prepare these Grignard reagent? For that, we need to take alkyl halide. Okay, let me take in general alkyl. R is alkyl. Alkyl halide is made to react to the magnesium metal. Okay, to give, now we require a solvent here, dry solvent. Generally, we make use of dry ether. Dry ether is taken. Okay, to give RMgX. RMgX. The carbon halogen bond breaks. Magnesium comes in between to give RMgX, called as the alkyl. Okay, alkyl magnesium halide. Alkyl magnesium halide, which is also called as the Grignard reagent. Okay, right? Now, what is the order of reactivity alkyl halide? Okay, alkyl iodides, okay, highly reactive to form Grignard reagent compared to the alkyl bromide and compared to the alkyl chloride. This is because the size of the halogen, iodine is a larger size compared to bromine compared to the chlorine atom. When the size of the halogen atom is greater, we can easily break carbon iodine bond. So magnesium can easily come and sit there. So it can easily form RMgX, okay, compound. Clear? Now this RMgX is a polar compound. It is a polar compound. Okay. It is a polar compound. Why it is a polar compound? Because RMgX, you know that magnesium generally loses electrons, so it is a electropositive metal. Halogens are electronegative elements, correct? So negative charge. Now R is here in this case act as the electron withdrawing group. So it is a R minus. Okay. So since there are the positive charges and negative charges on the molecule, it is called the polar molecule, polar compound. Polarity there. Polarity means plus and minus charges together. Okay. Now we are also using a dry ether, correct? Dry ether. Now which ether we are using here? The generally used ether is the diethyl ether. Diethyl ether. Diethyl ether. Formula is C2H5O and C2H5. Diethyl ether. Now what is the also what it does? It also helps in coordination with the magnesium metal. The oxygen contains lone pair of electron, correct? That will coordinate with the magnesium metal present in the Grignard reagent RMgX. Okay, so it will stabilize the Grignard reagent. It will stabilize the Grignard reagent. It's also called the solvation. It also called the solvation because the solvent is which one? Ether. Ether is the solvent. Try to stabilize the Grignard reagent. Process is also known as the solvation process. Okay. Now, Grignard reagent react with the active hydrogen. What do you mean active hydrogen? Active hydrogen mean hydrogen which are acidic in nature. Okay, acidic hydrogens are reactive with the Grignard reagent. Let me take example methyl magnesium iodide. Methyl magnesium iodide. Methyl is a negatively charged, magnesium is positive, and remaining here is a negative charge. Okay, so what I'll do, I'll break it into two parts. One is the alkyl part, other one the magnesium iodide part. So there is a positive part and negative part, positive and negative part here. It can react to the water molecule also. Water molecule. Water contains acidic hydrogen, correct? So the negative part, okay. So methyl group can act as a base here, can abstract the acidic hydrogen, okay, acidic hydrogen to give CH4 plus magnesium valence is 2, correct? One with the iodine, other one is the OH group, correct? Magnesium 2 plus charge, so it forms two bonds, okay, right? Now, CH4 is called as the hydrocarbon. Hydrocarbon. Remember, whenever Grignard reagent reacts with the compounds containing active hydrogen, they always give rise to the hydrocarbon. Okay. Now, let me take a say methyl magnesium iodide. Let me take alcohol. Even alcohols also acidic in nature, correct? Alcohols are acidic in nature. Phenols are acidic in nature, correct? Carboxylic acid also acidic in nature, right? Therefore, the negative part of the Grignard reagent can abstract that acidic hydrogen and it gives CH4, same compound CH4 plus magnesium forms bond with the iodine and OR remaining group. Okay. Grignard reagent also reacts with the carboxylic acid, and you know that carboxylic acid the acidic in nature, so it easily gives H plus ion, correct? So the negatively charged methyl it easily takes up the H plus to give the CH4 hydrocarbon, okay, and magnesium with the iodine here, and it is RCOO, okay, remaining group. Clear, right? Grignard reagent also react to the carbonyl compounds. Okay. What are carbonyl compound? Carbonyl compounds, those compounds containing a C double bond O group. Okay. So the basic three compounds I'm going to tell you. One is the aldehyde. It can react to the aldehydes. It can react to the ketones. It can react with the acid chloride. It can react with the acid anide. Now for timing, let me take aldehydes and ketones only. Okay. One of the simplest aldehyde is a formaldehyde. Okay, formaldehyde. Remember, formaldehyde when it reacts with the Grignard reagent, let me write Gr. It always gives a primary alcohol. Primary alcohol. If I take any other aldehyde other than the formaldehyde, other aldehyde always give rise to the secondary alcohols. Give rise to secondary alcohols. Whereas the ketones, if I take ketones, okay, all the types of ketone will give rise to the tertiary alcohols. Give rise to tertiary alcohols. So these are also the methods of preparation of the alcohols from the carbonyl compounds like aldehydes and ketones. So I'm going to write the reaction for all these. Okay. I said I'll take formaldehyde. Formaldehyde formula is H C double bond OH. Aldehyde groups are C double bond OH. Right? Reacts with the, I'm going to combine the step. First step is addition of the grignardine CH3 say iodide, methyl magnesium iodide. And second step is the acid hydrolysis. Let me write only H plus. Okay, so here it is CH3 minus remaining plus. So what I'll do, I'll take only the first part here CH3 minus and H plus. Remember, these are also called as the nucleophilic addition reaction. Remember, carbon, organic group goes to the carbon and H plus goes to the oxygen. Okay, shortcut it is. So I'll write H, C, O, H here, and here it is the CH3, which can be written as the CH3, then CH2 and OH. So this is the primary alcohol, correct? This is the primary alcohol, and this is the ethyl alcohol. Remember, formaldehyde gives the primary alcohol. Let me take any other aldehyde. Any other aldehyde is the CH3 here. CH3C double bond OH. Okay, I can keep on changing this group now, alkyl group. So I'll get a secondary alcohol. So what I'll do, I'll write the shortcut here. Okay, so I'll write a CH3 MgI I want only the alkyl group and followed by the acidification. There are two separate steps here. So organic group goes to the carbon atom and hydrogen goes to the oxygen. Double bond becomes single bond. So we'll be writing CH3, then COH here, then a new CH3 and then H here. Correct? Or this can be written as the CH3, COH, right? Then it is a CH3 and to the middle carbon atom hydrogen is there. So this is a secondary alcohol, correct? This is a secondary alcohol. So other aldehyde, this is the acetaldehyde. Any other aldehyde other than the formaldehyde gives secondary alcohol. Let me go for ketones now. Ketones, CH3, C double bond O CH. This is one of the ketone. This is the acetone. This is the acetone. Let me take Grignard reagent. So I'll write only R minus part and H plus here, correct? So CH3 minus goes to carbon, carbon goes to carbon and hydrogen goes to oxygen to form OH and carbon oxygen single bond. So we'll get CH3, then COH, then CH3, then again CH3. This is called the tertiary alcohol. Clear? Tertiary alcohol, right? Now let me take esters. Esters. Esters have formula RCOOR dash. Correct? I'll take two types of esters. One is let it be H for R. CH3COOH is a formic acid, and let me take a formic ester. Okay, so it is some alkyl formate. Okay, so it is a alkyl formate. Let me take one example: HCOO and C2H5. Ethyl formate. This is the ethyl formate. Ethyl formate. Okay, instead of hydrogen, let me take CH3. CH3. Okay, CH3COO C2H5. This is the ethyl. Ethyl. Okay, and this part is a acetate part. Ethyl acetate from acetic acid. Okay, clear? Remember here, when I take ethyl formate with the Grignard reagent, it gives aldehyde. It gives aldehyde in the first step. Again, it can react to the Grignard reagent. That means if I mention the Grignard reagent excess, then aldehyde will give finally the secondary alcohol. Okay. If I take 1:1 ratio, only aldehyde is formed. Similarly, if I treat with the 1 mole of the Grignard reagent, we'll get first ketone. Ketone. And ketone, if we treat with the again some more Grignard reagent, it gives finally the tertiary alcohol. It gives the tertiary alcohol. So let me write the reaction. How it happens? Let me take the formate ester. Okay, formate ester. H, C, double bond O. Okay, and C to H5. Let me take ethyl formate. Now let me take a CH3 minus from the Grignard reagent and followed by the acidification H plus. So what will happen generally now here in this case, the CO and oxygen bond breaks. So you write down CH3 this side and hydrogen here. So it will give now H C double bond O CH3, correct? This gives acetaldehyde. Remember, acetaldehyde it gives. And other product is what? Ethyl alcohol. Okay, we are not interested in ethyl alcohol now. We are interested in the carbonyl compound here. This again reacts to the Grignard reagent. You know that when acetaldehyde reacts Grignard reagent, finally gives what? Finally gives a secondary alcohol. So this is already explained in the previous slide. Clear? So this is only possible whenever there is an excess of Grignard. Otherwise, the reaction can be stopped at the acetaldehyde state. Let me take the ester other than the ethyl formate. So let me take the CH3, C double bond O, then O, C2H5, ethyl acetate. So the first part is CH3 minus from the Grignard reagent followed by acidification, correct? So break the bond here now. So CH3 to the CO group and H plus here. So we'll get CH3, C double bond O CH3. What I'm going to get? We are going to get a ketone. This is the acetone. And ketones on Grignard reagent, if there is excess, it gives finally the tertiary alcohol. Clear? Tertiary alcohol. Right? So there are two steps here. Second step is the excess of Grignard reagent. Otherwise, reaction can be stopped at the either acetaldehyde state or the ketone state. Clear? Next one is the acid chlorides. Now if I take acid chloride is treated with the Grignard reagent. Okay, Grignard reagent. And they give rise to ketones. And with the excess of Grignard reagent, ketones will give the tertiary alcohol. Tertiary alcohol. So let me write the acid chloride in general R, C, double bond O, Cl. This is acid chloride. Acid chloride reacts with the Grignard reagent. So let me write only the alkyl part. Second step is the acidification, correct? So we have to break the bond here. Break the bond. So CH3 to one carbon atom and H plus to the other. Okay, so we'll get R, C, double bond O, CH3. Okay, so here R is like a CH3, C, double bond O, CH3. So we get a ketone, correct? So we get ketones, correct? So ketones with the excess Grignard reagent gives finally the tertiary alcohol, explained already in the first slide. Okay, no need of writing again. Clear? Next one is the acid anhydrides with the acid anhydrides. Acid anhydrides with the Grignard reagent initially gives a ketone. Initially gives ketone. Again with the excess of Grignard reagent finally gives a tertiary alcohol. Gives a tertiary alcohol. What is the acid anhydride? Formed acid anhydride is the RCO. RCO twice. Okay. Attach the oxygen with the Grignard reagent. So let me write a CH3 minus first part. Second part is the H plus. Correct. You know that CH3 will attack the carbonyl group. So break the compound here. H plus goes to the oxygen here. Okay. So we'll get R C double bond O CH3. Other part is RCOOH. Okay. So we'll go for now Grignard reagent. Okay. Second step Grignard reagent now. Now this is a ketone, correct? Ketone. Ketones will give tertiary alcohols. Ketones will give tertiary alcohols. Clear? Next reaction with the epoxides. Epoxides. What are epoxides? Epoxide cyclic compound. Carbon carbon single bond attached to the oxygen. Okay. And there can be any other group here. Okay. There can be hydrogen. There can be alkyl group. Correct. So let me take simplest one. CH2, CH2 and attach the oxygen. This cyclic molecule has got only 3 atoms. Correct. In the cyclic structure. So it is more strained. It is more strained means it is less stable. Can easily react to the Grignard reagent. So let me write a CH3 minus only. So CH3 minus act as the nucleophile. Okay, and finally followed by acidification. So you know that carbon will attack the carbon atom. Organic group goes to the organic group and break the bond. Hydrogen, you write it here. So we'll get it as the CH3 attach the CH2 here. Correct. Next attach is CH2. Then here it is the OH. Correct. So this is the alcohol. So carbon number 1, carbon number 2, carbon number 3. So it is a propyl alcohol. So in this case we will get a primary alcohol. N-propyl alcohol, primary alcohol we are going to get. Okay. Suppose there are other substituents. For example, there is a CH2. Okay. Then a CH. Then write a CH3 instead of hydrogen. Then attach the oxygen. Now I'll write down the Grignard reagent CH3 minus and followed by acidification. You know that H plus will go to the oxygen. Correct. Now in the previous case, both were CH2 and CH2. Now, here it is a CH2 and there is a CH3. This is a bulky overcrowding atom is there. So, nucleophile easily attacks that position where there are no much overcrowding of the atom. So, it attacks the less hindered side. So, it attacks the less hindered side. Okay. So, less hindered side. So, Grignard reagent will attack the carbon atom which is not bulky group. So the bond breaks at this region here. Okay, so this CH2 will be attached to the CH3. I'll write like this. Then this is a CH, they attached to CH3, then attached to the OH here. Correct? Right? This is also secondary. This is a secondary alcohol. Correct? This is a secondary alcohol. Okay, but we can't tell if this is a secondary alcohol, tertiary alcohol. Depends on what? Depends on the groups attached here. Okay, so depends on the group we can have primary alcohol, secondary alcohol, tertiary alcohol. Right? Next one is the carbon dioxide. With the carbon dioxide Grignard reagent directly gives the carboxylic acids. Okay, carboxylic acid. So we have got carbon dioxide C double bond O, C double bond O. Then we have got Grignard reagent like let me write CH3 minus. Okay, first step, and second one is the H plus. Correct. You know that alkyl group here it is a nucleophilic attack the carbon atom and H plus will go to the oxygen. Double bond will become single bond. So This first C double bond is as such. Then new group comes CH3. Then we'll have got OH here. So in this case, we are going to get a CH3 COOH. We get a carboxylic acid here, right? Carboxylic acid. Clear? Next one with the alkyl cyanides. Alkyl cyanides with the Grignard reagent. With the Grignard reagent. First gives ketones. Again, it can react to the Grignard reagent to give finally the tertiary alcohols. Tertiary alcohols. So let me write down the reaction. Let me take a methyl cyanide CH3 C triple bond N. Okay, with the Grignard reagent. Grignard reagent is a CH3 Mgi. Let me write the full molecule of Grignard reagent CH3 minus and Mg plus. Right. So here it is a nitrogen is more electronegative, carbon is electropositive. Therefore, CH3 attack the carbon atom, positive carbon, and remaining part goes to the nitrogen here. Triple bond will become double bond. So you'll get CH3, then C double bond N Mg I. Then to this carbon atom we have got CH3. Okay. Now followed by hydrolysis. Okay. Now actual hydrolysis taking place. Hydrolysis means reacts to the water molecule. And here also bond breaks H and OH like this. So I'll be writing here CH3 C double bond O and it is a CH3. Now you can see here this is a ketone, correct? Ketone. Ketones if again reacts to the Grignard reagent excess, then it gives a tertiary alcohol. It gives rise to tertiary alcohol. Now here what is the other products here? I can write it that is remaining side product as the NH3, then magnesium iodide OH attached. Clear? Right? And the last one now with respect to alkyl halides. Alkyl halides. Alkyl halide. Alkyl halides with the Grignard reagent directly gives the hydrocarbon, higher hydrocarbon with the increase in number of carbon atom. For example, let me take a simplest one, methyl chloride. Methyl chloride react to the Grignard reagent, okay, CH3 minus, let me write first one, and second part it is like H plus, okay. CH3 minus is the nucleophile. Nucleophile attack the carbon of the alkyl halide, okay, and the bond breaks, and H plus will go to the chlorine here, okay. So I can write it as CH3 single bond CH3 hydrocarbon with an increased number of carbon atom, and I can write side product as the HCl. So this is a very simple way of writing the react to the Grignard reagent. Clear? Now we'll summarize whatever I taught you. Remember, formaldehyde gives a primary alcohol, other aldehyde gives a secondary alcohol, ketones always gives a tertiary alcohol. Formal ester first gives a other type of aldehyde, then gives a secondary alcohol. Other type of esters will give always ketones, and ketones will give tertiary alcohol. Acid chloride will give ketones, ketones will give tertiary alcohol. Acid anhydrous gives ketones, and ketones gives a tertiary alcohol. Only the carbon dioxide gives a carboxylic acid. They will not give primary alcohol, secondary alcohol, tertiary alcohol. Alkyl cyanide gives ketones and they give rise to tertiary alcohol. Epoxide gives alcohol. It can be primary, secondary, tertiary depending on the epoxide structure. Alkyl halide gives a higher hydrocarbon. Whenever Grignard reagent comes in contact with any compound containing acidic hydrogen, they give rise to the hydrocarbon. Right? Thank you for watching. Have a nice day.